Hello, everyone. Thanks for joining us again for another episode of the Amazic podcast. We're glad to have you here. I'm Twain Taylor, editor at amazic.com, and we bring you all of the coolest and the most interesting tech conversations around Kubernetes, cloud native, and we do a lot of coverage on the space. We do event coverage. We have regular articles that go up on our website. And we do this, which I'm really excited about, the podcast conversations that we have. And today we're going to be talking to someone from a really interesting company because they're the creators of a really popular open source tool in the Kubernetes cloud native space. It's called Kubescape. And it is a security tool for Kubernetes. And our guest will be telling us more about the tool in a bit. So the company is ARMO, ARMO Security, ARMO Security. And we have with us Craig Box. He's the VP of Open Source and Community at ARMO, a very exciting role. Very relevant as well, open source and community, which is a big part of cloud native today. And Craig tells me that he's, so Craig and me, we both worked at Google in the past at different times, so didn't know each other, but yeah, both Zuglers here. And Craig also tells me that he's in this, he has this being in this unique spot of being someone who primarily works out of New Zealand for an Israeli company, but is a company whose products serve the whole world. And so it's great to have you with us, Craig. Thanks for joining.
Thank you, Twain. It's a pleasure to be here in England today.
Oh, all right. Yeah, you're in England right now. So Craig, if you could start with telling us a bit about yourself and your background leading up to ARMO. I sort of gave a few hints in the intro, but if you could tell us a bit more about your journey up to ARMO, especially your time with Kubernetes, because I think that's one of the relevant points for this discussion as well.
Of course. I'd say that I've primarily worked in the area of DevOps. I started in it before it had that name. I was working in systems administration, but saying, well, hang on, what if we use some PHP scripts to automate building these config files and so on? So everything good is independently invented by many different people. I worked in New Zealand after finishing university there for an IT consulting company for a few years. And then, as all good New Zealanders do, I moved abroad, worked in Canada for a couple of years, and then ended up coming to England. And two important things there in terms of career. The company I was working at was, if you recall, the Symbian software that used to run on Nokia mobile phones and so on. So I was working with the open source foundation that was created by Nokia to make that available freely to everybody, sort of a predecessor and idea, of course, of things like the Cloud Native Computing Foundation. And then the work I was doing there was just as cloud was coming about. So it got me involved with working with Amazon for hosting, with Google for email and Google search appliances and so on. And that led on to doing consulting work, working with a company that was helping people get on board with Google Cloud. And that itself led to a job at Google, which I started in 2014. That was the same year that the team at Google were working on creating Kubernetes. That was the beginning of that journey. And I got in quite early there as someone working in the DevOps space, talking to customers based in Europe. There was a lot of going to people and saying, hey, this Docker thing is really interesting. You should go and look at it, but I can't tell you why. It's a secret thing we're going to be releasing in a few months' time. And I really was with the Kubernetes project for the whole journey, effectively, and worked in a few different roles, sort of helping the Americas team who were building things communicate with customers and prospects and communities and so on around Europe. Then eventually that became a global role, looking after go-to-market as we launched Google Kubernetes Engine, GKE. And then moving on into a formal developer relations role, which was really taking my passion for presentation, for podcasts and communicating with people and so on, and getting that with the entirety of the Kubernetes ecosystem. I founded a very popular podcast there, which I ran for the time I was at Google, communicating to the Kubernetes audience. And then also heavily involved with the Istio open source project, which is a service mesh that runs on top of Kubernetes. And so that journey was about 9 years at Google through to last year, where I decided that it was time to move on and join a startup, as people do.
Mm-hmm. Neat. So yeah, so you've done a lot of podcasting, and so yeah, that's great to know. Yeah, what was the move to ARMO like? What attracted you to ARMO?
I had come across ARMO in the role that I had, or the work that I did, at least with the Kubernetes podcast, was being aware of what happens in the industry and what's going on. And there were two things that happened a year before, which had happened in short notice. The first one was that the NSA launched their hardening guidance for Kubernetes. They published this document to say, if you want to run a secure Kubernetes environment, here is some configuration changes you'll need to make. Here are some things you need to be aware of. And about 3 weeks after that, it was literally that quick, the Kubescape project came about. It was a thing published by ARMO. It said, all right, here's this guidance that just come about from the NSA. Here is tooling that lets you check against that. Here is a way to validate your cluster complies with this guidance, that workloads you're deploying. And I think it was the first time that I noticed ARMO, and it was really to say, hey, these guys are doing something that is really innovative, but it's also very responsive. They're saying, all right, this thing has come out, and it's not like we're going to start building something in 8, 9, 10 months. But it was literally 3 weeks. It was being able to respond to that and have this project out there. And they'd reached out to me last year, and it was a very difficult decision, obviously, to decide to leave a very big, very comfortable company. But there were a few different things that had gone on in terms of life at that point. I had moved back to New Zealand after the COVID pandemic, and having been in the UK for a long time. And I had been working in a remote role anyway. So I was interested in saying, all right, well, I'm very interested in bringing my DevOps ability and Kubernetes connections and so on to this kind of space, to a role where I'm able to be more directly influential, where it's not so much about being in Europe versus being in California, where all the stuff in Google is done, but a chance to be at the center of things, even if I'm not physically there. And it really did seem that the cybersecurity space, the product they were building, the market that they had, all those things added up for it to be a very compelling conversation. And almost a year later, here we are.
All right. Wow, quite a journey.
Mm-hmm.
Yeah. And what was it like being part of the Kubernetes project from the very early days? Any memories, any funny stories, or any quirky things that you could share with us?
Yeah, I remember the first time I met Tim Hocken. I'd been talking to him. For people who don't know, he was one of effectively the creators, if you will. He'd worked a lot on the Google tooling internally, then Borg and so on. And he was the guy who came up with the logo, the 7-pointed star and so on. And so he had made the very first Kubernetes t-shirts. And I remember when I was in US for a trip, going over and going to meet him and grabbing one of those. And it's sort of a horrible light beige color, and it's got Kubernetes.io written uncomfortably in the Ubuntu font, it's offset underneath the logo in a very uncharacteristically Tim. Tim has great graphic design sense and taste and so on. And like everything about that shirt, except for that URL being printed on it, was great. And I do still have it in a drawer somewhere. It's very limited edition. He's made a lot more shirts since then. And he's a fantastic guy, great friend. And yeah, it just all sort of started over a t-shirt.
That's a collectible. Someday you can.
Very much so.
Do you have a picture of it? I'll try to edit it into our video later.
I'm not sure. In a very early presentation that I did in the UK, I may have been wearing it, but I was much younger then. I'll see what I can find for you.
All right, cool. So I want to get to our topic for today, which is security and open source, and really the combination of those two. Traditionally, open source was always seen as, the bane of security, and no one would want to touch open source if they're doing serious production, running serious production applications. But fast forward to today, that narrative has totally changed to where, you look at the cloud native ecosystem, and, it's all about open source. And now it's come to a point where you can't do security without open source. And, a lot of organizations see open source as very integral to security. Could you comment a bit on this transition, why it's happened, how it's happened, what were some of the key milestones?
Yeah, I had dinner last night with a friend who works at a very large, call it a governmental organization, if you will, here in the UK. And he was explaining to me their policy, which is basically like, we can't use open source. And I was very surprised by that, but it makes sense when you dig a level deeper. And it's basically like, you can't just pick an open source project off the internet and use it. You have to have a vendor who's willing to support that and operate it for you. And I'm sure a lot of the software they use is managed by their vendors at great expense, obviously. But that is the trade-off that businesses can make if they want to be companies that do whatever it is that they do, or departments that do what they do, versus being software companies. And so digging a level deeper than that, still say that open source is a thing that swept the industry in the last 20 years, in large part because it allowed upstarts like Google to come along and use technology that was out there at effectively no cost, and then build very compelling experiences for very cheap without having to worry about software licensing and the Sun Unixes and so on that were the alternative at the time in the late 90s. Is like, well, the Linux is getting to the point where it's able to do that. And so Linux is obviously the poster child. Mozilla and what became Firefox and so on was the poster child for desktop, when Netscape basically saw what happened with Linux and decided they were going to open source things. And when you look at where we've gone from there, like the argument from the commercial vendors was perhaps, well, people are going to be able to look at what's in the code and exploit it in a way that they can't do. But the opposite has really happened, is to say that there is an expectation now that you're going to be able to look at the source code of anything that you run and depend on. And even some of the largest vendors like Microsoft, for example, with the products that they run that are still commercial, you can get a license to privately go and see the source code. And it may not even require you going to a dark room and looking at it in the basement like it used to, but they will provide it to you so that you can audit it and do those evaluations yourself. Not so you can use it or share it, obviously, but that's a thing that you don't need to worry about with open source, is that you have the ability to do the auditing yourself, especially from a security perspective. But in general, you have a trust, and well-run projects will do things like get security audits and publish the results of them. And they'll have visible tooling there and say, you must have an approver that's not the person who committed the code, and you must have tests that validate various things. And just doing all those things in public, it doesn't really require the source code to be public, but it's a lot easier, and people worry a lot less about exposing those kind of things when it is public. So along with the shift that the industry has had to open source as a whole, and obviously vendors like Microsoft are very big on that from the position they were in 20 years ago, it is reasonable to assume that almost everything you deal with that isn't legacy today has an open source base, if it isn't open source itself, with the obvious counterpoint, I guess, that over that same period, we've moved a lot from software you touch to software that runs as a service somewhere else. And so all of the underpinnings, Google, as I mentioned before, and various other vendors who run software as a service companies, you don't really know what they're running. You're only dealing with it with some interfaces. And so you are trusting that they have validated everything and that they're compliant and so on. But very little of the software that we deal with ourselves today, with the exception of mobile devices, is useful in and of itself. It requires some backend, and that's, you don't necessarily see the source to that because you have that vendor relationship with the people who operate it.
All right, interesting. And as you talk to different organizations, what are some of the challenges that you see them facing when it comes to security in the context of cloud native and Kubernetes? What are some of the big gaps that you see existing in the market today? And probably hinting at, the approach that Kubescape takes and ARMO. But if you could touch on some of the challenges and the gaps you see.
Mm-hmm. Well, there are a couple of different angles to it. I'd say that if we take DevOps as a term that people throw around and sort of split it back into its two constituent parts, software engineering nowadays, such a library of code has been built up over time that very few people write anything from scratch these days. And unless you know what you're doing, especially when it comes to things like cryptography, you absolutely should not do that. You should pick something that works well with a commercial or open source. And all of these things that are out there on the internet, free for anyone to download and use, become a burden or a responsibility on those people to know what the situation is and to be able to fix it in the event that there's some vulnerability or something that they come up with. So there's been a lot of attention paid in software engineering to what is sometimes called the secure software supply chain. Is the idea of you need to know all your dependencies, you need to know the versions that they're at, and that someone who you've never heard of, who's 3 or 4 dependencies downstream from the code that you're writing, could introduce a vulnerability into your code, possibly through no fault of their own. But a lot of these people are burnt out maintainers who are saying, hey, I don't have time to maintain my little Node.js library or something. And there are also bad actors out there who are trying to buy their way into those projects and find a way to get code to run. So there's tooling you can run, there's analysis tooling and so on, and there's testing and things. But open source is like a puppy. It is a responsibility that you give to someone that they have to maintain. And there has been more of an acknowledgement of that over the last few years. The burnout, especially, like the fact that things like the bash shell that runs so much of the software that we depend on Unix, that it was effectively maintained by one person in their spare time, or getting to the point where it was unmaintained. And the same with so many different security libraries over time, is that there needs to be investment, quite probably from governments, to support engineering on these kind of things if they're going to become part of the national security conversation as they have in the US. So from the software engineering side, like that is one thing, is that the more code out there that you didn't write yourself, the balance of security is probably better because it's been audited by more people, but you still have to know what to do in the case when things do go wrong. Then moving over to the operational side of things, we see that in large part, you are unlikely to be attacked by a nation state unless you've done something very visible, but you are deploying software in these more complicated environments, and Kubernetes especially has made it possible to do amazing things, but it's still very hard when you think about all the knobs that need to be exposed to you for all these edge cases that you might not have, to make sure that everything's set the right way. And so we need to have guardrails, because like I say, you're more likely to shoot yourself in the foot, to misconfigure something or get something wrong through no fault of your own, than perhaps to attract the attention of an external attacker or a nation state or someone. And the reflection of that there in terms of Kubescape is to say, all right, well, like, there are all these things that you need to set. You probably don't need to have anonymous access so that anyone on the internet can address your Kubernetes API server. But the way that the internet was built to start with, and a lot of the early protocols and so on, come from those days where it was expected that everyone on the university was on everyone on the internet was effectively in a university and perhaps in the same one as you, and it was okay to leave things to be open. So there's really been a big shift again over the last 20 years as to who uses the internet. It's not just academics anymore. It's everyone. We depend on it for everything. And so there needs to be a lot more default closed, the whole idea of beyond corp and so on that Google published, is to say, well, we need to move to a zero trust environment where we have nothing is assumed, that we need to authenticate everything, and that we need to not allow public access to things, because even with the best intentions, there is a chance something will go wrong. And all of the options to expose these things, it surprises me that Kubernetes has APIs that let you just get access to everything. And of course, they are turned off by default in most cases, but they can be turned on. And if you misconfigure something, whether it's that or whether it's something on one of your workloads, you can open yourself up to a problem. And so having guardrails in place, having policies, having things that are able to check the environment. There are these great APIs. So you can say what the state of my workloads are. You can also see what the state of your clusters are, and use them to basically say, right, these are things that I want to say are okay for a user to deploy if they need to, but these are settings that say, well, these must never be deployed, for example. And you can make those decisions at a company level if you want to.
All right. Interesting talking about government and possibility of them getting involved with supporting open source security tools. And also the second part, which was about misconfigurations and how common they can be. And you spoke about access levels and zero trust. But digging a little more into that, I want to just find out about what are some of the issues. It's easy to say zero trust. It's easy to say, principle of least privilege, but then actually implementing them is the big challenge. Even though conceptually, probably understand what they mean, and we want to try. Everyone tries to achieve that. What are some of the obstacles or the challenges when it comes to making it a reality in your system? Could you talk?
And again, if we think back to the conversation I mentioned before with my friend who works at a very large, very traditional organization that have existed for hundreds of years, they will have software that's been developed and written since there was software. I'm sure that any kind of technology that's ever existed will exist in some way in that environment, and it will be depended on. It's very easy for us to say, as developers of modern applications, hey, we can build everything from scratch. We can write it in modern memory-safe languages. We can package it in containers from the word Go, in the language Go if we wish. But that's not how all software comes. And the assumptions that we need to make in order to secure things is, hey, we can run them, we can sandbox these things, we can set least privilege and so on. They don't apply to all the software that's out there, and it doesn't make it immediately easy to move everything. And there is a reality, especially the closer you get to those old-fashioned companies, those older companies, that you can't just throw everything away. You can rebuild things if you like, but lifting and shifting is still a big deal. There is a configuration option that you can set in Kubernetes to say basically the container should not have a root file system that you can write to, so that you run the entire thing in a read-only mode. It is a good best practice to have that enabled. It's one of the things that's in the NSA hardening guidance. A lot of software assumes that it's going to just be able to write data wherever it needs to, on the temp directory or so on, and that anything will be mounted and not just in a certain set of places. This is the same conversation that we were having 10 years ago about enabling things like SE Linux, is to say, if you know everything that your application can possibly do and you can lock it down to just those things, you can have a better security posture. But unless you're writing the application from scratch, your option is basically to watch what it does. And again, you might not have the source code to these applications. You might say, well, 9 times out of 10 when I run it, it's only going to write to these 4 directories. And then there's some use case that you haven't checked. And then on the 10th time, it's going to fail. And so the challenge here is to say, all right, well, how do we balance these recommendations and things that we know we should do with the reality that we don't necessarily have time or sprint points to rewrite everything to exist in this modern environment?
All right, all right. So we've spoken a bit about the challenges with security. I'd like to pivot now to talking about Kubescape. And if you could tell us why Kubescape, what it does, maybe a bit of its origin story, that'd be a great starting point for our conversation around Kubescape.
Yeah, so as we've mentioned before, I work for ARMO. ARMO started out building a different product. ARMO started out building a runtime security product. And that was based on the work that the co-founders had done in the security space before. But then as they went to their customers and the people that they were using this new product, they basically went to the security teams and said, all right, well, actually, we're doing things in a more decentralized way now. We're trying to push responsibility down to our DevOps teams and so on. So you really need to go and have conversations with the DevOps folks. And those teams would say, oh, yeah, this is great, but hey, we don't know what our security posture is. We're not able to look at the state of our clusters and our environment and check everything's okay. So this great security tool you've got, that might be useful in the future, but that's not where we are today. It's very much the same thing that happened with early Kubernetes conversations, is that we were going and saying, hey, you could do so much more with the number of machines you've got if you packed more containers onto them. And everyone said, oh, well, that's great, but we can't just reliably deploy software. And it was really interesting to hear about those conversations that happened before I started, that effectively led the company pivoting to doing DevOps facing security rather than CISO facing security. It was really about the tools that DevOps professionals need to be able to make sense of their environments, to be able to validate that they're safe, and be able to decide what order to fix things in when they are told there are things that need to be fixed. So as I mentioned before, the Kubescape tool, it was sort of in development around that time, but it really came into its own when it was the launch of the NSA hardening guidelines. And as other guidelines have been published and things have come out before, it's evolved to support them. It is a command line tool. You can also run it as an operator inside your cluster. And it will validate security posture against a set of controls. The controls effectively it's a security industry term. You think of them as little tests. We mentioned before, one control covers whether or not a container has an immutable root file system, whether or not it's effectively read-only. And so that is a test that you can run against every container in your environment, and you can say which percentage of them pass and fail and so on. And they aggregate up, and you can get a compliance score for your cluster and for the workloads deployed on it against the various frameworks. You can obviously define your own framework and say, well, I don't care about these ones, but I do care about this, and so on. Then it also implements image vulnerability scanning. and we're able to look at what's happening inside your clusters, know the vulnerabilities that are in each container that you have deployed. And there's obviously databases, CVE databases, and so on out there that make that possible. There's a lot of tooling around that. And that's tooling, again, because we're an open source project, we've been able to work with other open source projects and bring that in. So we actually use another open source project called Gripe, which is the engine for that. And then we can take that with the signals we get from the Kubernetes environment and with work that we're doing, which maybe touch on a little later about eBPF, to say, all right, well, here is not just the vulnerabilities that you have, but the way they should be remediated. And one of the key guidance for us as we develop Kubescape and then the commercial tools ARMO built on top of it is that it's all very well to know what's wrong, but it's how to fix it as well. We need to be able to say, these controls failed. Here is the fix. We've identified you could just set this particular parameter, or you need to change this thing. And the same with vulnerabilities, to say, well, I've been told that there are 1,000 different vulnerabilities in this package. Well, realistically, upgrading the base libraries are going to fix 900 of them, and then the rest of them, they are or are not important, and what order should I address them? Is trying to find a way not to overwhelm DevOps people who never had to think about security, to actually help them get their jobs done quicker.
Okay, really interesting. So it seems like scanning is one of the central components of Kubescape, the functions, things it does. So does Kubescape operate just pre-deployment, or does it also scan post-deployment production applications as well?
Yeah, so the most common way someone would get started with Kubescape is evaluating a running cluster. So if you just download it, then it will use whatever your configuration is for the kubectl tooling, and then it will scan that cluster, and that's able to get information about the API server and the configuration of the cluster, and as well as that the workloads that are deployed on top of it. You can kind of shift a little bit further right, first of all, if you will, by deploying an agent which runs on each node and is able to get more information about the operating system and things that aren't exposed, and get a more in-depth picture of your deployment. But then, of course, you can shift all the way left, and you can run Kubescape against YAML files that have Kubernetes configuration, against Helm charts, things as you're developing them, and integrations also for things like Visual Studio Code. So while you're working on these things, you're saying, all right, here's the configuration that I'm going to deploy to Kubernetes. You want to validate, once I have deployed that configuration, is it going to make my cluster less secure? And we have integrations for things like GitHub Actions that say, all right, well, if I push this particular thing to this repository, and we're working in a GitOps world here, so people are going to push a configuration change they want to make, it's going to be gated on approval in GitHub, and then it's going to go out to the cluster. So we want Kubescape, the tool, to be useful in all of those environments, to help people as far left as they want to go, whether it's at development or CI phase. And then when something's in production, also to be able to give them an overview and say, all right, well, yes, there are no security issues I need to worry about. I could trade off some engineering time for more security in these ways if it makes sense. And I can say, well, as far as my auditors are concerned, yes, I'm happy that I'm working to these guidelines that are published.
Right. And also you mentioned about Kubescape being able to suggest solutions to the issues that are found. If you could take us a bit under the hood and tell us what happens and how Kubescape does this. Is there a list of potential scenarios and solutions that are already there, and then those are matched, or how else does it work? How does that work?
Yeah, so many of the controls will be able to say, here is a resolution that's possible. So if you say there must be, one of the controls says, you must define resource limits. Kubernetes can, for every container you run, effectively, you can say it's allowed to use this much CPU and this much RAM. The best practice is that you should define those limits. Not everybody does, and not everybody may choose to. So if you choose to say, hey, I know I don't need to do that for this or at all, you can set up exceptions and ignore those particular controls in that case. But realistically, what you should do is again, inform your developer, hey, you're going to push this to production and it's going to make things a bit worse because you haven't done that. And then we can say, here are the things that need to be added in order to not fail the rule in future. And in this case, it's basically just you need to define these two parameters in your manifest file, but you need to come up with the values yourself. You need to know what the right thing is to do. So there's a little bit of both here. In this case, we can say, here is a assisted remediation. Say, we're going to assist you and say, here are the things you should fix. In the case of egregious errors, obviously, like if someone has the control plane configured wrong, we can say, hey, this is the exact thing that you need to fix. But at the other end, some of it is to say, all right, well, here is a thing that might cause you problems. It's not as simple as just changing a parameter, but you need to go away and think about it. And the fix in that point might be go read a blog post and decide if you want to re-architect everything. That's in the simplest case. That's where it comes to the controls and them having individual fixes. Then we start getting into some work we're doing at the moment around attack chains, is to say, well, if you have this vulnerability, it's technically a problem, but it's only a problem if the service is exposed. So what we now need to do is say, if the service is exposed and you have this vulnerability, then that might be attackable. And the same is true to say, if you have a vulnerability that lets you get access to the container, and then a vulnerability that someone who had access to the container could become root, now you have an externally exploitable root exploit because you're tying all those things together into a chain. And so we're doing a lot to connect those things together and to make it more obvious to people. Like we have a lot of the engine work there. It's worth explaining the difference between Kubescape as a command line tool and then the work that we're building a commercial product called ARMO platform on top of it, which is able to provide you with real-time visibility into your environments, but also help you a lot more with the identifying of what you should be addressing and when. And so a lot of the user experience around this stuff will actually end up in the ARMO product.
Okay. And is there any automated remediation built into the tool? Can you set up any sort of automatic response at all for any of the issues, or is it more an alerting system and then all of the action is on you?
It's upon you to decide if you're willing to accept automatic remediation. So the option is there. We can say, here is a thing. We find that most people are more interested in a button in the UI that says submit a pull request to make this change. Like we don't really want people to be automatically fixing these things because it will make some change. Like to the example before about the root file system, if you applied that remediation blindly without testing your application, something will break. And so in the most part, these things do require a little bit of human interaction, but for the ones that are obvious, then you can basically just apply them straight away. And so it's important to note also that we don't make changes to a running cluster. So the Kubescape tool effectively says, here are the things you need to make, but it's designed to not require access to make the changes to the cluster, in large part, especially because that's not the right thing to do, because your automation and your GitOps tooling that's looking at the state of things would just revert them if we applied them ourselves anyway.
All right. Yeah, that makes sense. So you already got us started on, just about ARMO and what it adds beyond Kubescape. You hinted at the main thing, which is it's not just a CLI tool. So there's the interface, but I'm sure there's so much more you guys are working on at ARMO. So could you tell us a bit more about ARMO, the product, and what more it has than the vanilla Kubescape?
Yeah, Kubescape is an open source tool. Very much think of it as a tool to be able to do the things we've talked about before. We take the output from Kubescape and we can export that to the ARMO platform, which is software as a service, is something that we operate. And you can use that to continually audit the state of your clusters, whether it be the configurations or misconfigurations or the applications that are running on top of them. We can also look at images deployed in container registries, and we can look at the configuration objects that are set in Git repositories. And we're able to take in the signals from those engines, again, using Kubescape as the underlying tool there. But that is really the start in terms of the presentation layer. The direction that we're taking this is to be able to look at many more different security things as well. So we'll talk a little bit more about what we're building out later on. But ARMO builds on top for the people who aren't necessarily dealing at the pipeline level, but who want the visualization. And so who want to be able to see, here is my estate over time, who want to be able to look at more than one cluster at once, who want to be able to show their auditors something and say, all right, well, we are aiming for this particular level of compliance. And so it's worthwhile for us to be able to say, we get this many points against the NSA guidance, for example, if they've chosen to adopt that as their metric. And then if we fall below that, if something is deployed which reduces the posture of our cluster, then we can be alerted to that straight away. So it really is that sort of single pane of glass comprehensive security view for your Kubernetes estate.
All right, really interesting. So you've actually prepared for us, Greg, this short video walkthrough of ARMO. So we'll watch that right now and then get back to our next question.
Kubescape is an open source security toolkit. It's built for developers, ops teams, and platform engineers because the responsibility for security is shifting left. Most people will start by interacting with the CLI, which I'm installing here, but it's also designed to be integrated with many other tools. You can scan your manifests while you're working on them in VS Code. You can set up a GitHub action to scan the repository with your manifest files, or you can use integration with Lens to view the state of running clusters. You can also install Kubescape in your cluster as a microservice. In just a few seconds, we've compared our security posture against the guidance provided by the NSA. Kubescape can submit its scan results to ARMO platform, where we can see the posture over time and dig into specifics about the failures. For this control, we can see all the resources that failed, including those that are either set to be ignored by the system configuration or by the user. When we see an issue that does need to be dealt with, we simply hit the Fix button for our assisted remediation, where we are told exactly what we need to change. ARMO platform also includes a comprehensive role-based access control visualizer, which lets an administrator see the roles and bindings on their cluster, and ask questions like which service accounts are mapped to which containers, or what unused administrator accounts exist. You also have full visibility into the vulnerabilities in your running containers, including upgrades that will fix them. And with our new relevancy engine, we calculate the subset of CVEs that we consider to be most relevant and that you should address first. A large cluster could have tens of thousands of vulnerabilities, so this feature makes it easy for you to understand which ones you need to prioritize.
Moving on, talking about ARMO, Craig, I want to ask about the integration with the CI/CD tools and IDEs. So that's a very key part, especially for the DevOps team, the application developers. So if you could talk a bit about that, how does ARMO integrate with these tools, and why is this integration important? What difference does it make, for it to be well integrated?
Yeah, the Kubescape engine can be integrated as a command line tool into many different places. I've mentioned before, for example, there's an IDE, there's an extension for Visual Studio Code. So as you're developing a manifest, if you were to do something like to say, this requires root access, like I'm going to run my container as root, then it can effectively pop up a little notice and say, all right, well, hang on, this isn't allowed. And it can run against either the default frameworks, or if you are an ARMO customer, you can configure it and say, all right, well, I'm connecting to my ARMO account and I'm downloading my company specific configuration. So I can say that this thing might be allowed by the NSA guidance, but me as a bank have decided that we don't want to allow use of this particular Kubernetes primitive. And by alerting people earlier, then they say that it's 45 times cheaper to fix a defect in development than in production or something to that effect. So the earlier you can fix these things and stop them getting in as a problem, the better. The same is obviously true. People develop in many different ways, and they're not necessarily looking at third-party software that they download. If you want to use a publicly available Helm chart, for example, you're not developing that yourself. Then you will, though, put that through your CI process, and you, again, might be using something like GitHub or Jenkins. And so you can use Kubescape as a gate there as well. You can effectively look at the configuration that you're going to deploy and then run the controls that make sense against that. And that will automatically say, all right, well, in this case, we are passing or failing based on these controls. And if you do fail, then you can flag that to somebody and say, all right, well, here are changes that need to be made, or I want to set an exception, an ignore rule up so that that is allowed, because in this particular case, it's okay. And it really helps the configuration of Kubernetes environments be code in the same way that that it has become possible, but to bring the guardrails that you would apply to code checking. If you check in a piece of code, it says, all right, well, here is a off by one error or something like that. It's a static analysis that's able to run. The earlier that you can offer that to people, then the less the chance of problems happening in production.
All right. Could you comment a bit about the different benefits that ARMO has for developers and for the ops team? Does it give immediate feedback to developers? Does it give ops teams better guardrails, as you mentioned? Could you comment a bit more about how each of these roles benefits from ARMO?
Yeah, and the question there, I feel, really is, do developers know they're running on Kubernetes when they're writing applications? That's something that's different for every individual environment and every customer. We've made a choice that we're not looking at security of code as such. Like, we are a quote unquote DevOps product or a Kubernetes product. So there are a number of good tools out there that will look at your code. And like, we can't tell you whether or not you're writing good, secure code, but there are other vendors who help in that particular space. The thing that sets us apart, and again, from all the vendors who look at cloud security as a whole, is we're laser focused on Kubernetes and the deployment people do to that, in large part because our experience collectively suggests that that's where people are, is where people are going, is using Kubernetes as the platform. So there's a lot to address there. And so a developer who's writing code or so on, they may wear an ops hat. They may also create the manifest that talks about how it's deployed, or that might be a different role. It might be that an ops team does that. But the interface, again, because it is now a piece of plain text in an editor, it feels the same way. It is sometimes committed to the same source repo, and it's not always though. So there are different teams and different roles who handle that. There are a lot of people who talk about just the Git repo for their GitOps object and so on, and configurations there. But someone who is a raw developer who's not dealing with operating things, they're not going to be touching Kubescape explicitly.
All right. You mentioned a bit about access controls. Previous to this, talking about zero trust security, and I want to dig in a bit more, asking about role-based access control and how it makes sense, and the approach that Kubescape and ARMO take when it comes to RBAC.
Yeah, so again, that's another broad area where there's just so much that you can potentially do and potentially do wrong. And this is very much a thing that attracts people to ARMO's commercial product. We do have some controls in Kubescape that are able to check for misconfigurations and things that are relating to role-based access control, and we will be building those out further. But on top of what's available from Kubescape, the ARMO platform has a comprehensive visualizer for access control. It has a lovely UI, which you will have seen in the demo before, that's able to show what the state of things are in your cluster, to say, well, what can this person do? Who can do what against this? And ask those kind of questions as well. And we are seeing people start to attack in that way. There are a lot of people who will be aware that like, don't create another, don't bind an account. So if you have a cluster administrator role that's bound to an account, and say that's bound to some sort of pod that's able to mine cryptocurrency or something, like that might trigger a response from people. But there are attacks that have been detected recently where people are creating a role that looks like it's a cluster administrator, but it doesn't have that exact name, or it touches right upon the detectable boundary. And it's the service account is called something like Kube Controller, which is very similar to the Kube Controller Manager account that already exists. And so being able to be alerted when there are changes, when there are roles created that have more permission before, that's very important, because in the event that there is an attack from outside, that is a way that people are trying to retain persistent access to your cluster.
All right. Interesting. And, I want to open up another can of worms, compliance, equally as RBAC. And it's becoming more complex with all of the different regions having their own compliance. How does ARMO handle compliance? This is probably not too much in Kubescape, I'm assuming, as an open source project, but probably more an ARMO specific thing.
No, it is a bit of both, and largely the ARMO platform gets its signals from Kubescape in this area. Okay. When it comes to compliance, like there are things that an auditor will come by and ask a bunch of questions, and it's not so much prepare an output from a tool. It's more like prove to the auditor's satisfaction that you are okay. Like when it comes to SOC 2, for example, like you need to be able to show, here are my policies for various things, and you don't guarantee that people are always adhering to them, but you can guarantee that there's a policy that says everyone has signed this, for example. When it comes to Kubernetes security, like a lot of places will want you to validate that you are doing something good. And these hardening guidelines and various benchmarks and so on, they can be used as part of that, is to say, well, currently the industry says best practice is that we align with this particular benchmark. There's one published by the Center for Internet Security, CIS, and they started out with a benchmark that says, here is how we are against Kubernetes as a concept. And that has a variety of tests and things that make assumptions that you're running your own control plane. When you start using a managed service, GKE, EKS, AKS, for example, they don't make sense anymore. You don't have the ability to change those things. And so you can't say whether or not you pass or fail, or worst case, you'd have to fail against all of them. So we've been working with the versions of those benchmarks that have been published. We've released one for Amazon EKS, and I think Azure is very soon, if it's not out already by the time this video is out. But we need to be able to support those specific things. And so if you're a customer who's using one of those environments, you basically have a customized version of this particular benchmark that you want to be able to validate against. You're able to do that, see your compliance against that for your particular environment. And then that will help you in your auditing to get some sort of compliance standard.
All right. Interesting. We're trying to close last few questions. But I want to ask about, the balance between building ARMO and working with Kubescape as an open source project, and just what that means for ARMO, because of course, a lot of organizations in this spot of building a business on top of an open source project. If you could comment a bit on, your views on that, that approach, and, in terms of how do you prioritize what to focus on, what to build, in terms of product features. Mm-hmm. That's one way of looking at it. But the other way is also, what are the benefits of, that ARMO gets, from being involved with Kubescape as a project. There's various angles you could, look at this from, but just like to get some of your key points on just this whole topic of building a business on top of an open source project.
Yeah. So the business angle comes down to decisions that were made before I joined, and that are largely aligned with why I joined, is that there are companies out there doing cloud native security. There are companies out there who are doing security who have a Kubernetes or an open source component, but it's not key to what they do. But there was no one out there who was doing full open source CNCF project security. This was the first security scanning toolboxy kind of project donated to the CNCF. Which is strange to some degree. Like, we would have assumed that maybe one of the other vendors in this space would have donated one of their tools, but they didn't. And so that was the choice that we made, is that we were going to do that, and that we're going to build up this thing as a community project. We're going to do a lot of work to make it useful to everybody. We're going to try and be an independent, neutral tool, which does make it hard to commercialize some things. Like, there are companies that don't need to have the separation. So MongoDB, just to take an example, like their open source thing and their enterprise thing are named the same, but that's something that you can't do when you're a vendor and your open source project is in the CNCF. They have different names. And so that's where sort of ARMO and Kubescape have to be kept separate, as is true for many other commercial CNCF projects. So it was a decision that we made because, first of all, like the CNCF is where people look in the Kubernetes space. That is definitely a signal that people take, and the status as people move through levels in the CNCF is a signal we take as to, is this something that's going to survive? Is this something that's maintained by vendors from different places that's going to live well over time? And as we want to be part of the Kubernetes conversation, like that is an area to be. Like, there are, as I say, a lot of great tools built by people that are useful on top of that, but they are more aligned with the vendors who build them. And so there's an opportunity there, we felt, to align more with the community. That said, obviously, we hope that the more people who use Kubescape and get value out of it and so on, that many, if not all of them, will go on and look at ARMO and see what happens. But there are some cases where people will be happy with that tooling. There are even some cases where other vendors who build things that could be considered competitive to what ARMO do will use Kubescape as their engine. And that has happened indeed recently. We worked with that team to help that happen. Like, that is the point of open source, is we are able to consume components to help us do things like build out image scanning, just as other people are able to consume our open source. And that is the ecosystem working as intended.
Mm-hmm. Really cool. I want to ask about some of the early results that ARMO's customers see once they start using the product in maybe a few days or a week or two.
Yeah, so you can get a result. We say it's 3 minutes. I think that's still about right in terms of saying, right, here's my compliance against this particular framework. And that's useful. Like you can get instant results and say, all right, these are the things I need to go away and fix. Some of them you'll need to consider whether or not you want to fix, but it's a really quick, this is the state of my environment. Then as we start talking about image vulnerabilities and so on, the state of your environment doesn't change very much. Like you'll deploy things every now and then, but you're generally just deploying a new version of a thing and making some changes. Vulnerabilities is where we see it really mattering, is that new software comes out much more frequently than you make changes to your clusters and configuration. So the thing we're seeing people get real value out of is really around some new features we're building around vulnerability relevancy. Mentioned before that we're using eBPF, which is effectively you can just think of as a way to tap the kernel on a particular node and ask it questions about what's going on. We're able to look at what files are actually being loaded into memory from a container when it starts running. We run a little agent on the node. It says, all right, well, you're running all of these things. In the first few minutes, we touched these files. There are so many vulnerabilities that show up in container images that relate to the base image or the package manager that was installed on top of it or so on, or some dependency of that aren't actually executed. There's a critical vulnerability in something like if in the RPM database. And so that might affect every container you've got that's built on top of something that uses RPM. Like, well, that might be a problem if someone could get onto your node, but realistically, like that's not your own application. That's not the thing that matters. It's never loaded into memory. And so we really want to help people understand the prioritization order of things to look at and say, well, these things actually are loaded into memory. There's a medium vulnerability in this one. Maybe we'll suggest you look at that before you go look at the critical things and people aren't actually able to execute. And so that we feel is where we see people get real value. It's being able to cut through the noise and to get an idea of what it is that they need to operate on. And that's useful for people whose goal with this is to fix security, for people whose goal is to demonstrate to someone that an environment is secure. Then obviously having the graphs and dashboards and so on in ARMO, or the UI output, the text output in Kubescape is really helpful there as well. So those are the two primary things we see people want out of a security solution.
Right. All right, cool. Last couple of questions. I want to ask about, could you give us a teaser of one of the exciting features coming up on ARMO's roadmap?
Yeah, so we've been looking a lot at what are the things that people expect that they should be able to do with a Kubernetes security solution? Where are the problems that people have in this space? There are a lot of tools out there that do evaluation. eBPF, as we mentioned before, is this way of being able to say, here's a way of seeing all the process access. And we could use that to do intrusion detection, but then you have to run an agent that runs and uses a lot of memory. And there's various trade-offs there as well. But we see a lot of these open source projects who address one of these little security spaces. And what we're trying to do is say, we want to be the tool that you install in your cluster and that it takes the best of breed of all of these things. And we're working with a lot of people here. We're working with one of the projects dealing with the eBPF agents and so on, and saying, well, how can we collectively build something based on the work you've done as a consumer of that to help power this relevancy stuff, to help power network access checking and so on. So we're building out a roadmap for a 3.0 version of Kubescape, effectively. We're in the 2-point-somethings at the moment, but the next version is going to say, all right, well, here are some security things that we think everyone should be able to do. And we're sort of surprised that people aren't dealing with really easily. Being able to check an individual image for vulnerabilities, you can do that with the Gripe image scanner itself. You can't do that with Kubescape today. But then being able to say, all right, well, if we were to build that in, then the CI integration we've talked about before can say not just this manifest file will introduce this misconfiguration or not, but to be able to say, well, it will also introduce this many critical vulnerabilities. And we don't necessarily have that runtime information to say that it was whether or not they'll be loaded in your environment, but it can give you an idea to say, well, actually, you're running Nginx 28, and it turns out that version 30 is available. And if you were to change your manifest to say, I'm going to run that one instead, then you'd have only half the vulnerabilities. And so when you do get into production, there's less to deal with. So we're building out a lot of integrations and tooling that feel like they should be there, that draw these things together and take the best of a few different open source projects and bring you one tool that helps do everything you need to do.
Wow, really exciting. So for someone watching this who wants to get started, how do you recommend? Do you recommend they try Kubescape first, or is there a trial for ARMO? How do they get started?
So ARMO is free forever for up to 10 worker nodes, and you can install the Kubescape agent inside your cluster, and it will report the data back from that. You can also submit the results if you do just a command line scan. You can submit them and view them in the ARMO platform as well. So you can check out armosec.io, armosec.io, or click on the lovely link below the video to do that. And then if you're interested in hacking on the Kubescape project or the engine behind things, then a link down there for our GitHub page as well.
All right, cool. That was a really fun conversation. I really enjoyed hearing all about Kubescape and its scanning and just the way it helps to secure Kubernetes, which is really the big challenge today for a lot of organizations as Kubernetes becomes more and more complex. I was excited to hear about that. It not just tells you the problem, but even gives you the solution and how to fix things, prioritizes them all. So some really cool stuff there. So before you go, Craig, I've got a couple of questions to get to know you a bit more. Yeah, it's fun. So let's go. The first one. What would you say would be your alternate career if not for your job in tech?
I almost went down the path of going into radio. I'm not sure that radio still exists now. And being that I ended up doing podcasting, I could say that kind of ended up being the same thing. But did a little bit of work in radio through high school and university. And I think that would have been a fun place to be.
What kind of channels?
Oh, it was pop radio, I guess, what they call contemporary hit radio. And I also enjoyed the automation behind things as well. So that was back when there was playlists and voice tracking software was becoming a thing. But they had these special sound cards in the computers that were running the radio station that could do MPEG-1 audio, because MP3s were just sort of becoming a thing around that time, and they'd probably crash if you tried to build your radio station to play on it. But,
did you have a cool name for, is RJ something, or was
no, nothing like that. I was never that kind of cool, but I did a couple of shifts on a very large radio station in New Zealand, but that's all consigned to the history books now.
All right. Complete the sentence. Open source is.
Ooh, open source. There was an exhibition at the Victoria and Albert Art Museum in London a few years ago I went to, called David Bowie Is. And I think that was just a sentence all in of itself, and that was fine. So perhaps we'll say open source is, and we're very thankful that it is.
All right. Which open source project you spent the most time with? I'm guessing maybe now it's Kubescape, but if you can tell us something apart from Kubescape.
Yeah, so I'm still very much involved with the Istio project. That was something that was started when I was working at Google, and I worked on a lot throughout. It also addresses a lot of security use cases, and there's a lot of overlap, I think, for people who want to be able to do zero trust security and so on. And one of the great things about working in open source, perhaps one of the other things that open source is an opportunity to stay involved with something even when your employment changes. So when you're working somewhere else, like that isn't working specifically on selling something based on Istio, I'm still on the steering committee, and I'm still helping it. Recently led it into graduated phase of the CNCF. So it's still something that's appreciated for people to be involved, and it's a great community.
All right. Istio is part of the CNCF, is it? No?
It is something, again, I've been working on over the course of the last 12 months.
Oh, all right. I think that was probably in the past year, right? Because before that, it wasn't.
It was very famously not in the CNCF for a period, but that's a conversation for another podcast.
Yeah. Wow. I got to read up on that. Working with the open source community, you probably wear a lot of hats, but which of these roles most resonates with you? Developer or marketer or a teacher, trainer, or product guy, or something else?
Most of them, some of the time. Not normally development, so I wouldn't really want me to write the code that's going to end up in production. I have a computer science degree, but it's never been my interest to do the low level kind of stuff. Right now, I'm doing primarily product stuff. I effectively saying that to build a good open source thing, you need to use the same mentality that you use to build a good commercial thing. And so the Kubescape 3.0 project that I mentioned about before, I'm acting as the product manager for that. So I'm helping pull together the requirements, and the ARMO team will build out a large sum of this, but I'm also acting as a mentor to 3 community students from the LFX mentorship project that the Linux Foundation run, who will help build some of that out too. And so it's a bit of everything. So I'm working as an executive, I'm working as a marketer to some degree, having conversation with you now, and then I'm doing a lot of product stuff. I'm doing a lot of operation stuff as well. Like I'm always looking at our products and saying, all right, here's bugs, here's reporting, here's things that could be done better. Being a critic in the good sense of the word is saying, like, my experience having used tools like this will influence our opinion on how they should be built. So I think it's really helpful to be able to wear many different hats.
All right. Really cool. With that, we come to the end of our discussion, Craig. It was quite a talk, and I really enjoyed it. I'm sure our viewers as well got a lot from it. So if you want to know more about ARMO, definitely go to their website, armosec.io, and connect with Craig. I guess, Craig, you're active on LinkedIn, maybe Twitter.
Yeah. So for a period, I was saying, oh, I don't know if I can tell people to follow me on Twitter, but it seems Twitter survived. It came out the other end. It's still there, and hopefully it continues to be. But I'm at CraigBox on Twitter, or mastodon.social, or anything else. But
All right. Cool. Well, all the best, Craig. It was great having you with us. Thanks for joining us. And thanks for our viewers as well for tuning in for another podcast. And we hope you'll join us again for the next one. See you. Thank you.